question 20, a very challenging question. I'll read it through first. Which substance reacts with trichloroethene to give a chiral product? Okay, so you need to know your reactions of your alkenes essentially, and you need to know what a chiral species is. Okay, so there's two concepts there that need to be fully understood. And it's not at all easy because of all those organic chemistry reactions you have to learn. It's a tricky one indeed. So, first of all, the way I looked at this, I said to myself, I can rule out this and this, okay? And the reason I can do that is because when we think of the reactions that we need to know about our alkenes, remembering that alkenes have this double bond, okay? I'm just gonna draw a very simple alkene here. Alkenes have our double bond there, which is a region of negativity, okay? Negativity. So that's a negative region there. So in other words, what is going to attack this region here in the reaction mechanism is the electrophiles. So these two here, the cyanide ion and the hydroxide ions, these do not wish to attack this negative area. These are actually nucleophiles. They like regions of positivity. However, our bromine dipole leads to this being an electrophile, and our hydrogen here in the hydrogen chloride is also electrophile. So I've narrowed it down now to options A and B. Okay, so it's very important you've just got in your head what are the common electrophiles and what are the common nucleophiles. I've just copied in a list here. This is probably too extensive really, but you can see we've got our bromine there and our hydrogen there on our electrophile side, and we've got our cyanide ion there and our hydroxide ion there on our nucleophile side. So very important you have this in your head, the list of the common electrophiles and nucleophiles. Okay, so now we need to choose, is it A or B? Let's work it out. Okay, so I've very messily drawn in our trichloroethene there, okay, and I've forgotten to put the double bond in. So now there's our double bond. Okay, so we're talking about electrophilic addition here. So basically what's going to happen here with both of these species, we're going to be breaking the double bond and adding on what's here in the options, okay? So let's have a look at what products we form. Okay, so for our bromine, what we're doing is adding on those two bromines, and we're producing this, this compound here, okay? Now for our hydrogen chloride, let's see what happens. Okay, so for our hydrogen chloride, this is the product we're going to get, and it doesn't really matter where this has actually gone to or where this has gone to, okay? But let's just say I've chosen that they're the ones that are going there, okay? Right, so that hasn't really got us closer to the answer unless we really understand this idea. What is a chiral product, okay? Okay, so this was the best explanation I could find for what exactly a chiral product would be, okay? So if we look down here, we're looking at the idea of symmetry, okay? It says a molecule which has no plane of symmetry is described as chiral. And for it to have no plane of symmetry, essentially what you've got to have is 4 different groups attached to the central carbon, okay? If we have that unique kind of arrangement, then we have basically what we'd say is a chiral compound. So let's go back and look at these and see which one is chiral. Okay, so if we take this as the central carbon here, okay, you can see quite obviously that we've got 1, 2 groups attached, or in this case it's atoms attached, that are the same, okay? So it's not going to be chiral. If we took this here to be the central one, then again, it's the same issue, okay? You've actually got 3 groups attached to this carbon that are the same. In other words, it will display symmetry. So this is incorrect, meaning that the answer has got to be A, Br2, and let's just show why that is the case, okay? If we take this to be the central carbon, then we've got 1, 2, 3, and 4 different groups attached to that central carbon atom. So this is the chiral center, and it's a chiral product because, if we skip forward again, because A molecule which has no plane of symmetry is described as chiral, and the carbon atom essentially has to be attached to 4 different groups to be described as chiral. So I hope that helps. Bye.